Welcome back. In this video, we're going to expand on our understanding of exponential functions, and we're going to take a look at the concept of logarithms. And logarithms, while sounding pretty complicated, it's really just a fancy name for exponents. So when you hear about logarithms, you got to think exponents. So let's take a look at exponential form. Exponential form is, some base A. We have here is some particular base A raised to the y power gives you some particular answer x. Okay, so that's our answer. So, for example, we could have like 2 raised to the third power equals 8. So our answer is 8, our base is 2, and our exponent is 3. So some base A raised to a power y gives an answer x. That's what we're looking at here. Now, if we wanted to rewrite this into exponential form, into logarithmic form, we'd say log base A of x equals y. So log base A of x equals y is just rewriting our exponential form here into logarithmic form. So if I wrote 2 to the third equals 8, well, my base is 2, so log base 2 of x. Well, x was my answer, so log base 2 of 8 equals, and then in this case my y was my exponent, so there's my exponent, so log base 2 of 8 equals 3. So if we look at logarithmic form, log base 2 of 8 equals 3, we can kind of convert back into exponential form in our head. Log base answer equals exponent. Okay? And you may want to memorize that. Log base answer equals exponent is what you would do to convert logarithmic form into exponential form. Log base 2 of 8 equals 3. So log base answer, here's my answer, equals exponent. So log base answer equals exponent. So when you have logarithmic form, you can help yourself by memorizing this. Okay, that's going to be your way to convert this into exponential form. Log base answer equals exponent. Log base answer equals exponent. Okay, so we'll need to be able to write things from exponential form into logarithmic form, or go from logarithmic form into exponential form. So here you see examples of logarithmic form. 3 to the second power equals 9. My base raised to a power equals my answer. In logarithmic form, log base 3 of 9 equals 2. Exponential form, I've got 1/5 raised to the negative second power equals my answer of 25. So log base answer equals exponent. We can work in the other direction. Log base answer equals exponent. So my base is 10 and my exponent is 3, so 10 to the third equals my answer. And another final example, log base 4 of 1/64 equals negative 3. So log base answer equals exponent. So I'm saying here 4 to the negative third must equal 164. 4 to the negative third equals 164. So 2 to the fifth equals 32. Well, that would be written as log base 2. 32 equals 5. Log base answer equals exponent. So I will save this one for you. I'll let you do that one and bring that to class. And I will do the next one here. Log base 8 of 4 equals 2/3. So there's my base. 8. 4 is my answer. Right? That's my answer in exponential form. And 2/3 is my exponent. So 8 to the 2/3 equals 4. Does that really work? Well, fractional exponent, we have power over root. So do we have the cube root of 8? Squared, does that equal 4? Well, the cube root of 8 is 2, so we get 2 squared equals 4. Yeah, that checks out. So that works. That makes sense. So log base 8 of 4 is 2/3. And I will let you go ahead and convert this final one from logarithmic form into exponential form. Next thing we want to talk about is solving logarithmic equations. So, solving a logarithmic equation, our process is as follows. You'll want to write this down and have this in your notes. You want to rewrite logarithmic equations into an exponential equation. So you'll have to use the skills we just learned above. Then you will want to follow the process for solving an exponential equation. So when you solve an exponential equation, each side must have the same base. So you'll have to rewrite each side of the equation with the same base, whether it's base 2 or base 5. And you will have to use your laws of exponents here to help you out and apply those laws of exponents. Once you have the same base and you apply the laws of exponents and simplify those exponents, you will drop the base and rewrite the equation using only the exponents, and then you'll solve for the variable. So let's take a look at some sample problems. You're going to be asked to solve these logarithmic equations. So log base 3 of x equals -3. So log base answer equals exponent. So in exponential form, might as well start with our first step. That would be 3 to the -3rd power equals x. Well, I don't really have to rewrite this as base 3. Hopefully we know that 3 to the -3rd is the same as 1 over 3 cubed equals x. And 3 cubed is 27, so 1 over 27 equals x. So log base 3 of 1 over 27 equals -3. And that we have just confirmed or rewritten that anyway into logarithmic form. But that's our answer. Sample problem 2. Log base 1/3 of 2x plus 5 equals 2. Looks pretty complicated, but 1/3 is our base. There's our answer. Equals our exponent. So in exponential form, we get 1/3, our base, raised to some exponent equals 2x plus 5. 1/3 squared, that would be 1/9 equals 2x plus 5. I have one variable. I'm just going to go ahead and solve for x. I'm going to subtract 5 from both sides, and that would be minus 45 ninths. So I get a negative 44 over 9 equals 2x. So I multiply by both sides by 1/2. And we will get x equals, I can simplify that to negative 22 ninths. So x is negative 22 ninths. Third sample problem, log base x of 5 equals 4. So log base answer equals exponent. So I'll rewrite it into exponential form. X to the 4th equals 5. And this really, well, we want to solve for x. So if I take the 4th root of both sides, I get x equals the 4th root of 5, or x equals 5 all raised to the 1/4 power. And if we think about this, now we know what x is. If we look at that and we say x equals log base 4th root of 5 equals 4. What we're saying here is log base answer equals exponent. So what this is the 4th root of 5 raised to the 4th power equals 5. And those are inverse operations. So the 4th root and the 4 would cancel out. We get 5 equals 5. So that seems to check out. Our fourth and final sample problem looks pretty complicated. Log base 36 of the 4th root of 6 equals x. So log base answer equals exponent. There's my answer. There's my exponent. So rewritten into exponential form, 36 to the x power equals the 4th root of 6. I can rewrite the 4th root of 6 as a fractional exponent. So I'm going to do that. 36 raised to the x power equals 6 to the 1/4 power. So now my instructions, original instructions seem to apply here. If I get the same base, I can probably get this to work out. 36 is 6 squared to the x equals 6 to the 1/4. So 6 to the 2x equals 6 to the 1/4. I have the same base 6. So then I can just drop the bases and work with my exponents. So 2x equals 1/4. I want to multiply both sides by 1/2 to solve for x, and x equals 1/8. So log base 36 of the 4th root of 6 equals 1/8, or 36 to the 1/8 equals the 4th root of 6. So there are some nice sample problems for solving logarithmic equations, and we will see you in class.